In section 1.4, we're learning about arithmetic sequences. What are they, you might ask? Well, it's a set of numbers with a common difference between each term. You've likely dealt with an arithmetic sequence, maybe even as a kindergartner, just looking for patterns in a set of numbers. Now, down here on this thing, we see that difference is highlighted. Remember, difference is just how many there is between a number and the next number. So say it's from 3 to 8, we would say the difference is 5. We'll work through a few examples here to show you how we'll use that. Another vocab word that might come up is the word recursive. This just means it's kind of a repetitive pattern. We're using the previous term to find the next term. So if something's recursive, it kind of builds upon itself. It's like a list of numbers. Finally, explicit would be like a magic formula, if you will. It actually tells us how to find a term in a sequence without knowing the previous term. We're going to do some examples here to put these vocabulary words to use and make a little bit more sense of them. You'll see this document that I have on this page here. We're going to work through it. You likely got a copy from your teacher. And a few things, the answer key and the document, I guess, itself are located on Canvas, so you could find those or fill out the answer key at any time. Let's get started. So while arithmetic sequences may sound a little confusing or scary, let's just first look at this table. We have the numbers 1, 2, 3, and 4. Those are standing for the terms, so we're going to let n represent like the term we're dealing with. So if I say term 1, we'd say term 1 is 3. Term 2 is 8. Term 3 is 13. Kind of just like, which value is it? Now, we're going to look at the pattern. Term 1 is 3, but term 2 goes to 8. What's the difference? Well, we'd need to add 5 to get from 3 to 8. Term 2 is 8, term 3 is 13. What's the difference? Oh, again, it's another adding 5. Turns out that 13 plus 5 is also 18. So the first term starts at 3, and we add 5 and continuously do that. When that happens, that is what we call the arithmetic sequence. If we go back a page and look at our definition of arithmetic sequences, that's the set of numbers that have a common difference between each of them. Well, this looks to have that. So in our first column, when it says, is the sequence arithmetic? We're definitely going to answer yes in this one. Now, this next column says, what is that first term? Well, we know our first term here is the 3. The common difference we found is 5. We can write a plus 5 if we want to, or just 5 is fine as well. Now we get into some things that we're not so familiar with. Recursive formulas again, are ones that use previous terms to find the next term. Well, we know that, for example, here, when I was looking at the 8, if that was the previous term, I would have to add 5 to get to the 13. So we're going to write some formulas that are recursive, but we need to know some notation. Down here, you'll see I have the word subscript and function. You've probably seen something like this before, but let's talk about what these mean. A sub 1 or A of 1, they both mean the same thing. This will both represent what we call our first term. Kind of just a mathy way to write, hey, this is my first term. We use these notations. A sub n or A of n is the nth term. Any term you could represent it as. So it could be the 5th term, the 22nd term, you name it. Now, A sub n minus 1 or A of n minus 1, that would be the previous term. We use this a lot with recursive because it does build on the previous term. So let me just give you an example of it here. I'm going to start with our function notation for our recursive formula. For this example, I would write A of n, that means any nth term, could be achieved by taking A of n minus 1 plus 5. That means you're taking your previous term plus 5 to get your current term or your nth term. Now, we want to always tell someone where to start when we're doing a recursive formula. So if someone said, hey, just keep adding 5, you might say, to what? Where do I start? So we're going to write my first term, A of 1, In this case, hey, we actually noted that, it's 3. That's how we write a recursive formula in function form. Let's try subscript form. Not much is going to change. I like to think of it as the n shrinks. We'd say a sub n equals a sub n minus 1 plus 5, and we'd also let them know that a sub 1 equals 3. They say the exact same thing, but we need you to be aware of how that notation changes. Now you'll notice that eventually we're asked for the 100th term. No one probably wants to make this table out to the 100th term. That's where explicit formulas come in. It may be easiest if I just show you this explicit formula and we'll talk about why it is the way it is. So we would say if you want any nth term, a sub n, we would say you'd start with your first term 3 and add 5, which is our difference, times n minus 1. Again, 3 is our first term, and 5 is our difference. Now, we can simplify this, but we'll do that in just a second. Let's test this out. If you were to take, say, in your n, and you wanted the, let's say the third term. So if I wanted the third term, I want this n, this highlighted n here, to be 3. Okay, so if I put 3 in there, 3 take away 1 would be 2. 2 times 5 is 10, and 10 plus 3 is 13. Let's go check. Over here on our table, oh look, the third term is 13. If you use this general form, you will always have your explicit formula. One thing you may be asked to do, or at least recognize, is to simplify this. We're going to use that distributive property where you would multiply this 5 through those parentheses. That's going to give us 3 plus 5n minus 5. I can combine the 3 and the negative 5 to give me, leave my 5n first, and 3 take away 5 would be negative 2. This is just a little bit prettier and more simple way to do it. Let's try it now. If I put my 3 in there, 5 times 3 is 15, take away 2 is 13. We still get our third term to be 13. And what's great now is I can use this formula to find my 100th term. I can simply plug in 100, and then I'll subtract 2 into that explicit formula. So when I want that 100th term, a sub 100, I put in my 100 into my equation. Well, let's see, 5 times 100 is 500. Take away 2 would equal 498. Way better than making a table. Let's try another one. Check out our table. We start with our first term is 7, our second term is 5. We notice the difference. Remember here, it seems to be going down by 2 each time. As long as it's a steady change, yes, we can say it's arithmetic. Our first term is 7, and our difference, it is going down by 2, so we do want to indicate that with our negative 2. Our recursive formula, we're going to write both our function and our subscript, so we would say, and again, this is very patternistic. You can keep writing the same type of thing. The only thing that changes is our difference is now 2, and our first term is 7. My subscript notation is almost the exact same, just my n's kind of shrink, and my difference this time is minus 2 here. So minus 2, where my a sub 1 equals 7. For my explicit formula, I'll say of a of n will be my first term 7, and my difference negative 2 times n minus 1. I'm going to simplify that here, and I get 7 minus 2n plus 2, because a negative times a negative is a positive, which would leave me with 2n, and 7 plus 2 is 9. To find my 100th term, I'd go ahead and plug that 100 into my equation. Now, I probably should make that negative there. My apologies. Make sure that negative comes down with there. So I'd have negative 2 times 100 plus 9, and that would give me Negative 200 plus 9 would equal negative 191. In our third example, first term is 5, so I did get rid of my headings here, but my first term is 5, and my difference, let's look for it. So this one is growing by 5. Oh no, this one is growing by 10. This one grows by 20. Well, oh no, but oh yes, we don't actually have to do this problem because no, it's not arithmetic, so it doesn't have any of the rest of this. On our fourth example, we see our first term is 20. Let's check for our difference. Looks like we're adding 1.5 here. Oh, and adding another 1.5. This one does appear to be arithmetic. It does add 1.5 every time, so that is our difference. We would write our recursive formula in function notation. That's a of n equals a of n minus 1 plus 1.5. And we need to tell people where to start, so we'd say a of 1 equals 20. And now our little n shrinks. And finish out my a sub 1 is 20. For our explicit, remember we have a of n. We always start with our beginning term, then put on our difference plus 1.5 times n minus 1. Simplify that through a little bit more of a decimal math here. We've got 20 plus 1.5n minus 1.5 leaves me with 1.5n plus 18.5. Now I want to figure out my 100th term. I'll just put that 100 into the equation and add 18.5. I will get 168.5. All right, so looking here at example 5, I see the first term is negative 2, so I've written that here. And the first time it goes from negative 2 to 6, that'd be adding 8. But now it's going from 6 to negative 12, and that is not adding 8. No matter what's going on here, it is not arithmetic, so we can move on, and we do not have to do that one. On number 6, our first term is 12, and I see it goes to 20, so that would be adding 8. 20 plus 8 is 28. We are in business. It is definitely arithmetic, and our difference is adding 8. So let's write our recursive function formula. A of n equals a of n minus 1 plus 8. We're always adding 8 to the previous term. We want to let someone know where to start. A of 1 would be 12. Now we shrink our n's to do our subscript notation and let someone know that a sub 1 equals 12. Our explicit, we would say, now you can actually write explicit with some subscript, so I'll just do that for fun here. Instead of writing a of n, I could do a subscript n. A sub n equals always my first term plus my difference times parenthesis n minus 1. Now normally I would use that, I can keep it as a large n there. Let's distribute that through. So I would say 12 plus 8n minus 8, and that would give me 8n plus 4. So I could say a sub n equals 8n plus 4. Now to get my 100th term, someone could ask you, what's a sub 100? They can ask you in a subscript or a function notation either way. We still use our equation, 8 times 100 plus 4. So how about 804? One thing to note, you could actually put your 100 in here if you want to. So if someone would ever say, oh, I took 12 plus 8 times 99, because 100 minus 1 is 99, this would give you the same answer as that, but I tend to use my simplified equation if I have it. This entire answer key can be located on your teacher's Canvas page, or you can also try some more examples in your packet, but we find this to be the most clear way of introducing arithmetic sequences.